Python __call __ special method practical example. I know that _call __ method in a class is triggered when the instance of a class is called. However, I have no idea when I can use this special method, because one can simply create a new method and perform the same operation done in _call __ method, and instead of calling the instance, you can call the method. I would really appreciate it if someone gives me a practical usage of this special method.
This example uses memoization, basically storing values in a table, dictionary in this case, is so you can look them up later instead of recalculating them. Here we use a simple class with a _call method to calculate factorials, through a callable object, instead of a factorial function that contains a static variable, as that's not possible in Python. Now you have a fact object which is callable, just like every other function. For example, and it is also stateful.
I find it useful because it allows me to create APIs that are easy to use. You have some callable object that requires some specific arguments and are easy to implement because you can use object-oriented practices. The following is code I wrote yesterday that makes a version of the hashlib.foo methods that hash entire files rather than strings. This implementation allows me to use the functions in a similar fashion to the hashlib.foo functions. Of course, I could have implemented it a different way, but in this case it seemed like a simple approach.
Yes, when you know you're dealing with objects, it's perfectly possible, and in many cases advisable, to use an explicit method call. However, sometimes you deal with code that expects callable objects, typically functions, but thanks to _call you can build more complex objects, with instance data and more methods to delegate repetitive tasks, etc. that are still callable. Also, sometimes you're using both objects for complex tasks, where it makes sense to write a dedicated class, and objects for simple tasks, that already exist in functions, or are more easily written as functions. To have a common interface, you either have to write tiny classes wrapping those functions with the expected interface, or you keep the functions functions and make the more complex objects callable. Let's take threads as example. The thread objects from the standard library module threading want a callable as target argument, i.e. as action to be done in the new thread. With a callable object, you are not restricted to functions, you can pass other objects as well, such as a relatively complex worker that gets tasks to do from other threads and executes them sequentially. This is just an example off the top of my head, but I think it is already complex enough to warrant the class. Doing this only with functions is hard, at least it requires returning two functions, and that's slowly getting complex. One could rename _call to something else and pass a bound method, but that makes the code creating the thread slightly less obvious, and doesn't add any value.
Django Forms module uses _call method nicely to implement a consistent API for form validation. You can write your own validator for a form in Django as a function. Django has some default built-in validators such as email validators, URL validators, etc., which broadly fall under the umbrella of regex validators. To implement these cleanly, Django resorts to callable classes, instead of functions. It implements default regex validation logic in a regex validator and then extends these classes for other validations. Now both your custom function and built-in email validator can be called with the same syntax. As you can see, this implementation in Django is similar to what others have explained in their answers below. Can this be implemented in any other way? You could, but it will not be as readable or as easily extensible for a big framework like Django.
If you want to support the channel, please consider liking and subscribing.